Hello and welcome to the video. In this video we're going to be looking at solving a linear pair of simultaneous equations using the substitution method. There is also another method to solve simultaneous equations, that is the elimination method, and there will be a link to that video down in the description below. Here is an example of what a pair of linear simultaneous equations looks like. In this video we're focusing on linear equations, so that means that when we look at our equations, there are no higher powers of x or y than 1. So when it comes to solving equations like this, our first step when using the method of substitution is to look for an equation where one variable is the subject of the equation. We can see that this second equation has x by itself on one side, and that is what it means to be the subject of the equation. In this example, it's already been done for us, but we'll look at another example in a second where we would need to do that. The solutions that I'm looking for when I'm solving simultaneous equations should satisfy both equations at the same time. So that means any value of x should be the same in the second equation as in the first equation, and same with the y's. So this x in the second equation should equal this x in the first equation. Now this x in the second equation is also equal to this y plus 2 on the right hand side. And so my job here is to now replace the x in the first equation with that y plus 2. Always remember to place brackets around the thing that you're substituting in. So now we have on our hands an equation with only y. This is a linear equation now with one unknown variable, which we can solve. I'm going to expand out this bracket. We can quickly simplify this left-hand side by grouping the y's. Let's subtract 2 from both sides, and finally divide both sides by 5. So this has given me the value of the y. Now we are going to have to find the corresponding x value. To do that, I'm going to do a second bit of substituting. I can see that my y value now must be equal to 1. So in either the first equation or the second equation, I can replace that y that I've successfully found the value of. It's probably easier to do that for the second equation. So I'm going to go in and replace that y with what I found. Habitually, I'm going to put the brackets there just to build up that habit. And simplifying that, we can see that x equals 3. The nice thing about simultaneous equations is that we can always double check our answer. So we can now take 1 and 3 and place those values back into both of the equations and double check if the left is in fact equal to the right. And if I work that out, 3 plus 4 times 1 is 3 plus 4. That is indeed 7. For the second equation, the left-hand side is 3. The answer for 1 plus 2 is indeed 3. So you can always take your pair of answers, your x and y value that comes out after solving, place them back into the equations to double check your answers. Now let's look at a slightly more complicated example. This question is still reasonably nice because we can see that in the first equation, we already have y as the subject of the equation. That means we don't have to do any rearranging. We can identify that any y that I see in this set of equations must be equal to 5 minus 2x. Here's a y, so my first substitution is going to be replacing that. So to do that, let's write down the second equation. And remember, we're keeping everything else the same, only replacing the letter y with what it's equal to. So I'm going to write the minus 2 exactly the same, then remembering my brackets, replacing the y with 5 minus 2x. And here you'll see the importance of adding those brackets when we're replacing. Now I'm going to need to expand out that bracket with the minus 2 in front of it to get the correct answer. So minus 2 times 5 is minus 10, minus 2 times minus 2x is positive 4x. Simplify the left-hand side, we combine the x terms to get 7x, minus 10 equals 4, add 10 to both sides, and finally divide both sides by 7 to get the answer x equals 2. Now remember we have to do a second substitution. I now know what my x values are equal to, so I can go back into one of these equations above, identify an x, and replace it with the value of 2. So working that out, y will equal 5 minus 2, And then I'm going to add in my brackets, replace the x with its value. Working out that right-hand side, I have 5 minus 2 times 2. That'll be 5 minus 4. So the value of y will be 1. Now I'm going to do a double check. So for the first equation, we have 1 equals 5 minus 2 times 2. Yeah, that is correct. That is 1 equals 5 minus 4. 5 minus 4 is, of course, 1. Let's put those values into the second equation now. 3 times 2 minus 2 times 1 is 6 minus 2, which is indeed 4. Okay, so we've used that second equation to double check our x and y value. Let's have a look at a slightly harder question now. We can see in this case there is no letter that is the subject of the equation straight away. So our job is to identify which letter can become the subject of the equation in preferably the easiest possible way. If we look at the second equation, we can see that there is a y by itself. That makes it the easiest equation to manipulate. So we can simply subtract 3x from both sides of the second equation to get y equals 17 minus 3x. So I'm just going to temporarily cross out that second equation because now I'm going to be working with this rearranged form. What I'm going to do then is identify that my y variable is equal to this expression in terms of x. I'm going to look into my first equation and find that y is here. So we're going to do our substitution as before, remembering to replace the y with brackets around the x expression it is equivalent to. So make sure to correctly expand out these brackets. This is where a lot of students make mistakes, especially when we have negative signs in front of that number. Okay, so we've expanded out the left-hand side. Let's simplify that. 13x minus 51 equals 1. Adding 51 to both sides, we get 13x equals 52. And so dividing both sides by 13, we find that x is equal to 4. As before, I'm going to take my x back into one of the equations to find the value of y. Using my rearranged form, I get that y equals 17 minus 3, and then in the brackets I place the 4. Working out that right-hand side, we get 17 minus 12, so y equals 5. And as before, you can double check this answer if you would like to. Let's have a look at one last example. This is the hardest question that we've looked at so far to solve with the substitution method, but it is still possible. Let's identify a variable to rearrange to make the subject of the equation. I'm going to choose this y here. I think that's going to be the easiest. So I'm going to first subtract 5x from both sides of that top equation. Then I'm going to divide both sides of that equation by 3. It might look a little bit of an awkward form at this moment in time, but it will become a little bit simpler when we start to plug this in. I like to leave my stuff as fractions as well. In fact, in this case, you can only really leave your numbers as fractions as we're dividing by 3. If you find this rearranging of equations difficult, there's a link to a video in the comments down below that will help you with solving equations. So we can identify in the second equation where my y is. I know what my y value is equal to in terms of x. So we're going to do our substituting. Keep the 7x the same. Coefficient of minus 4 is brought down. And in brackets, I'm going to place in what I have found my y to be equal to. Now we've got that in, let's do a little bit of simplification. I'm going to bring that 3 out. So I've got the over 3 now multiplied on the outside of the bracket. And to make life a little bit easier for myself, I am going to multiply both sides by 3. So I'm dealing with integer numbers. Don't worry about the level of difficulty with the numbers in this question. You won't be asked anything this complicated if you're doing a non-calculator paper. If you were doing a calculator paper, though, you would be expected to be able to do something like this. Let's expand out our bracket. Let's do a little bit of rejigging. So we've got 41x equals 287, and dividing both sides by 41 will leave us with x equals 7. Final step then, replacing one of the x's in our initial two equations with the value 7. So I've chosen that first equation, subtracting 35 from both sides, and finally dividing both sides by 3 to find that y equals 3. As before, you can take this x and y pair, place them into both equations in order to double check that the left is in fact equal to the right hand sides of those, and I definitely recommend you do that, especially in your exams. But that brings us to the end of this video of solving equations using substitution. These are the linear equation questions. In a separate video, we'll be looking at one quadratic and one linear sets of simultaneous equations. So I'll link that one in the end cards below. But I hope you enjoyed this video and hope to see you again.